Hello, my name is Garrett Barker, and welcome to the virtual symposium of the Hardware Checker for Fixtures Capstone project. The technical directors on this project are Vicor employees Alfred Binder, Product Engineering Manager, and Nathan Shake, URI alumni of 2020 and Associate Test Engineer. Our consulting technical director is Mike Smith, a URI alumni of 2001 and the founder and principal designer of Bold Circuits, LLC. The team for this project comprises of two team members, Daniel Hartnett and myself, both majoring in electrical engineering. The company behind this project is Vicor, a Massachusetts-based company incorporated in 1981. Vicor is a leading global power and power module technology, selling their projects to the power systems market, high-performance computing, telecommunications, transportation, defense, and many more fields throughout the world. The motivation behind this project is to expedite the internal and outside testing as well as troubleshooting of probe cards made for this company. The hardware checker can confirm the testing software being used works properly and detects hardware malfunctions. This will help manufacturers with troubleshooting and quality assurance of the cards. The anticipated best outcome for this project is to create multiple functioning hardware checkers that will be able to test each of their intended probe cards rigorously. Primary testing and coding will be conducted on the P0, 13, 14, and 37 probe cards, as well as extensive testing on the P0, 55 probe card. The key technical accomplishments for the fall 2020 semester have been the completion of code for the P0, 14 probe card, along with testing multiple P0, 14 cards with such code. Significant progress has also been made on the P0, 13 and 37 bump and trim card variations. Completing all code for ZID cards and beginning extensive testing on the P0, 37 bump and P0, 13 trim variants. As for the economic impact of this project for the company, the hardware checker is anticipated to increase overall efficiency by reducing development time by 10% and reducing debug time by 50%, saving both company time and resources. Here is a block diagram of the hardware checker, showing the process of testing a probe card and determining the steps to take depending on the outcome of the test itself. It shows how simple the debugging process becomes with a hardware checker, enabling most engineers to easily utilize the device and its benefits. My individual contributions to the project include completing the code for both the P014 and P013 probe cards, working to maintain similar standardized naming conventions for each card. The coding included developing tests for the capacitor, timing, and high-low driver components of the cards. I also had to verify the values of voltage and current through certain components such as pins and resistors to ensure the valued quantity was running through a certain pathway on the card schematics. For future contributions to the project, I will test P013 probe cards with my completed code along with other probe cards that arrive and need further testing. There are also possible plans for a cable checker that work will begin on in spring 2021 semester. Now allow me to introduce my other team member, Daniel Hartnett.
So again, here's a look at the functional block diagram, and it really showcases how much easier the debugging process is with a hardware checker and that any engineer can quickly find the highlighted issue and solve it. Some of the technical contributions I was able to complete were writing code for all the tests of these probe cards, the majority of the tests being voltage current verification tests, forcing a voltage or current, then closing or opening some relays and taking the measurement to verify it reached its desired location. I also developed cap tests for the high-low sides of drivers, and designed a new test that would verify no current leakage. I was able to live debug the probe cards on the tester, learned how to disassemble probe cards from their needle cards, and then just recently I have begun updating the code for a new hardware checker called the P055 trim. Here are two snippets from schematics I was given. On the left is the timing page of a P037 probe card. Here I would force a volt that would come in from the pins on the left and then figure out which relays to have closed or open to get the correct path to an APU pin where I can take a measurement to make sure it got there, verifying that all the relays are working and there is good connection everywhere. On the right is the test I made for verifying current leakage in the P014 probe card. By forcing voltage at the APU and closing the top relay, I could take current measurement at the same APU. I then could open that relay and close the next one down and do the same process. To verify this, I took a delta where I subtracted the new current measurement from the old to verify that it comes out as 0, and if so, then there's no current leakage. To develop the cap test, I needed to ramp current. In the top left, you can see the code sample. This was done for every cap on the schematics. It begins with a ramp of 0 current for 50 samples and ends with a ramp of 0 for the last 50 samples. In the middle of that, there is a positive current ramp for X number of samples and the same negative current value for X number of samples, formulating a nice triangular digitized graph. This made for the most efficient and accurate calculation of the capacitance. I used the ETS RAID tool to look at the digitized graph of the cap, and when connected to the tester, the graph will show the yellow line, but it will be the nice triangle. It is shown better in the photo to the right. This made it easy to choose which 2 voltage points to use to get a good dV value. Once that is done, the capacitance is calculated using the Ohm's law equation. As for future contributions, in the coming spring semester I will be continuing work on the P055 trim card and testing it in the lab. There has been a discussion to possibly design an ETS system resource checker if there is time, but I know there are more hardware checkers to get done after the 55, so we will have to play that by ear. As a team, our future technical accomplishments will be to continue working on the current hardware checkers we have now and completing them, and then begin work on more that need completion. There are possible plans for a cable checker and an ETS system checker, but those are still in discussion as time could play a factor in whether we get to them or not. We would like to thank our technical directors Al Binder and Nathan Shake. They have been amazing mentors and supported us with every task we have been given. We would also like to thank our consulting TD Mike Smith. His expertise in PCB design is a very helpful tool to have by our side. And of course, none of this would be possible without Dr. Sunak, our Capstone Program Director. You continue to encourage our creativity and inspire us to work our hardest. Thank you.